Hello everyone, my name is Kumar Aditya, and in this video I will try to explain the principle of amp-second balance in a capacitor. So this amp-second balance is also called as charge balance, and it simply says that if you apply a periodic voltage across a capacitor, then the average current flowing through the capacitor will be 0. That is that DC component of the capacitor current will be 0. Now to understand this statement, I have created this circuit here. I am using this voltage source to apply a periodic voltage across this capacitor, and we will plot the current flowing through the capacitor and we will calculate the average value of this current. So if I run the simulation, on the top I have the voltage generated by this voltage source, and on the bottom I have the current flowing through this capacitor C3. And if you see this voltage waveform, it is periodic in nature. It has a time period of 2 milliseconds and it is repeating with the same pattern. If you consider an instant, let's say this instant, you can see the initial value of the voltage 2.4 volt, and after 2 milliseconds it is again coming back to 2.4 volt. So this waveform is periodic in nature. Now this is the current flowing through the capacitor, and let's see whether its average value is 0 or it is not equal to 0. So if I take the average of IC3, it is 11.6 picoamp, very close to 0. Now it's not perfect 0 because this is a SPICE simulation and the capacitor and the voltage source have some non-idealities, but you can get the idea that if you apply a periodic voltage across a capacitor, the current flowing through the capacitor will have no DC component. Also you can understand from this graph, the average is what? Average is area under the curve. So in a time period we can calculate the average value of this current, which will be simply area by time base. So area of this rectangular block plus area of this rectangular block divided by 2 milliseconds. Now this area is what? 4 milliamp into 1 millisecond, and this area is what? Minus 4 milliamp into 1 millisecond by time base 2 milliseconds. So this is amp, this is second, right? This is again amp, this is second. So you are doing a amp second balance. So within it, for a periodic voltage across a capacitor, net charge stored by the capacitor will be 0. Amp second is what? Amp second is the charge. We know that current is rate of flow of charge, right? So dq is I dt and its unit is amp second, right? Or coulombs. So coulombs is amp second. So we are essentially doing a amp second balance when we apply a periodic voltage across the capacitor. Now why it is important to have this amp second balance in a capacitor? To illustrate that, I have created this second circuit. In this circuit I will violate the amp second balance, and to do that I am using this current source to generate a periodic current, and this periodic current has some average value, that is, it has some DC component. So let me plot the waveform. On the top I will plot the current due to this current source. So this green trace, and you can see it is periodic in nature and it has an average value of or DC component of 2 amp. So I am allowing a DC current of 2 amp through this capacitor. Now let's see the voltage across the capacitor due to this current, and you can see the current voltage across the capacitor keep on rising. As long as I keep on applying current which has some DC component, the voltage across the capacitor will keep on rising, and eventually this capacitor will get damaged, because you know that capacitor has maximum voltage rating, certain maximum voltage rating. So it is very important to follow this amp second balance principle. Now you can also understand it using mathematical expression. We know that current through a capacitor is given by capacitance times rate of change of voltage, or we can in other words say that voltage across the capacitor is given by integral of current divided by the capacitance, right? Now if this current is DC, right, if it's constant, then we can take it out and dt simply becomes the time. So as long as you keep on applying this fixed current through the capacitor, then voltage will also keep on rising. So this is what is happening here. This periodic current has a DC component of 2 amp, and I am applying this current for almost 10 milliseconds. So time is rising, time is increasing, and therefore this voltage is also increasing. So I hope you understand what is the importance of amp second balance. Now I have this last circuit. There is one more important point to understand when we are dealing with the capacitor in DC to DC converters. So I have this circuit here, and essentially I am applying a periodic voltage. Let me plot that. So this red curve is the voltage generated by this voltage source volt 1, and you can see this is periodic in nature, right? So as per this statement, amp second balance statement, for periodic voltage average current through the capacitor should be 0. So this is following a amp second balance, but still there is some issue with this circuit. Even though this is following a amp second balance, this is not recommended to have such voltage across the capacitor. You can see this voltage is changing from 0 volt to 4 volt almost instantaneously, and similarly it is changing from 4 volt to 0 volt again in a very short time span, almost instantaneously. Now coming back to the same statement, same mathematical expression, I is equal to C dV by dt. What we are doing here, we are changing dV from 0 to 4 volt or from 4 to 0 volt in a time interval approximately close to 0. So if your denominator of this expression is 0, then current will be very high. And if I plot the current here due to this such voltage, let me plot it in the bottom plot. You can see at each transition I have very high current through the capacitor. So this is 4 kilo amp for this particular example. So eventually it will evaporate your wire bond or whatever is present in this current path. So there are two things which you should care about when you are using capacitor in a DC to DC converter or switch mode power supply. First is that the voltage across the capacitor should be periodic in steady state. In transient, we will see in the next video. In transient, we usually violate amp second balance principle. And second thing is the voltage should not change instantaneously. So it should be periodic, but it cannot change instantaneously like this. So it's okay to have ramp kind of waveform, it's okay to have sinusoidal kind of waveform, slowly changing. This is also slowly changing, but it's not okay to have such kind of waveform. It's not okay. This is okay, this is okay, this is not okay, because it's changing almost instantaneously. So I hope you understood what is amp second balance and why it is important to maintain amp second balance. In next video I will demonstrate the amp second balance principle being followed in a DC to DC converter. So till then, bye bye.